Good morning. How are you? Hope you are all in the pink of health. I am Atunurai and you are watching Bond Making and Bond Breaking channel. This is the last video of alcohol, phenols and ethers. And those videos that I am given to you, that is not only for the HS. It helps you on NEET. It helps you on JEE as well as the other exams also. So please see all the videos perfectly and honestly. This is my request. Okay. So now today I am going to discuss you on some questions and some important name reactions. Okay. Then this chapter is finished. Now the first question is which is given you that one is butane. The first question is one is butane and another is ethanol. Two groups. Okay. So if we compare this, butane means CH3, CH2, CH2O, butane. This is not butane, so if this is butane, so this I give you CH3, butane, and ethanol, CH3, CH2OH, ethanol. So if we compare their molar mass, so we see that C4 4 into 12 plus 1 into 3 to 5, 5 to 7, 7 to 10, 1 into 10. So this is 48 and 10 means 58. Molar mass is 58. And if we compare this, we get C, so 12 into 2 plus H, 3, 5, 6, 1 into 6 plus 60. We get 24, 6 plus 16, therefore 46. Okay, 46. This is 58 and this is 46. If we compare this molar mass of butane is high. What is it? Molar mass of butane is high compared than ethanol. The molar mass of butane is high compared than ethanol. So as we know that the boiling point is directly connected with their molar mass. Okay. So according to this rules, the butanes have more boiling point compared than ethanol. But if we see their data, the data is 78.3 degrees centigrade and it is near about 5 degrees centigrade, minus 5 degrees centigrade. So now we see that the boiling point of this compound of ethanol is high. So if we compare with boiling point with molar mass of the butane is high. So it should be the butane have more boiling point compared than ethanol. But the figure or the data does not say it. So what is the reason behind this? The reason is hydrogen bonding. Hydrogen bonding. There is oxygen. Oxygen means electronegative element. So it can perform on hydrogen bonding. But there is weak van der Waals force of attraction. So it cannot It cannot act on or it cannot react on hydrogen bonding. So it cannot give their performance on the hydrogen bonding. So due to this hydrogen bonding, ethanol shows higher boiling point. Okay, this is the first important question. Now, second important question. And the second important question, alcohol shows both acidic nature and basic nature. Alcohol shows both acidic nature and basic nature. Explain. How? This is the question. This is the second question. So I give this answer with the reaction. ROH, I write in this way, ROH. Okay, it reacts with NH2. N has lone pair, so it attacks this H. So you give RO minus. So it releases the hydrogen and ammonia. So as it is released this hydrogen, it is called acidic reaction or acid. So it behaves like acid. Lone pair attack this hydrogen and this alcohol groups release its hydrogen, so it shows RO minus. So this proof that alcohol reacts with or behaves like acid. Okay, now I give you the next, ROH, and it reacts with H2SO4. I write in this way, H2SO4. Okay, H2SO4. Now the point is it reacts like RH2. It accepts the H plus, so ROH2, H2 plus and HSO4. Okay. So this reaction proves that it accepts its hydrogen. So when it accepts its hydrogen, so it behaves like basic nature. So those two reactions proves that alcohol behaves more both acidic nature and basic nature as well as. Okay, this is the second answer. This is also very important answer. Now the third question. Now the third question is acidic order. Acidic order. Now the third question is acidic order. Acidic order: 1 degree, 2 degree, 3 degree alcohol. If we compare these alcohols, which is more acidic? 1 degree alcohol means HC, or I can write in this way, CH3, CHOH, CH2H. So one bulky group. So this is 1 degree alcohol. If we write CH3, OH, 2 bulky group is here. So this is 2 degree alcohol. If we write CH3, CH3, OH, CH3. So this is 3 degree alcohol. 1 degree alcohol, 2 degree alcohol, 3 degree alcohol. Which is more acidic? So acidic nature depends on the compound's tendency to release the H plus. But I said acidic nature depends on releasing H plus. Okay. So you see that the inductive effect of this group, it pulls the electron on the oxygen. So the density of oxygen is increasing. So its tendency to release the hydrogen is decreasing. What I say, the inductive effect of this group is high, so it pulls the electron towards the oxygen. As it pull the electron on the oxygen, the density of oxygen is increasing, as well as the tendency to release hydrogen is decreasing. On 2-degree alcohol, 2 bulky group is here, so the process of pushing electron towards the oxygen is increasing. So the tendency to release hydrogen compared than 1 degree is less. It does not wants to release of hydrogen easily as compared this 1 degree. And on the 3 degree has 3 methyl group. 3 methyl group means 3 bulky group. 3 bulky group means more inductive effect. More inductive effect means the pooling process of the oxygen of electrons is high. So the density of oxygen is high compared than, or is higher compared than the 1 degree and 2 degree. So it cannot release its hydrogen easily as compared than 1 and 2 degree. So the acidic nature depends on releasing hydrogen. So the releasing process or releasing tendency, if we compare those 1 degree, 2 degree or 3 degree alcohol, we see that 1 degree alcohol shows more easier. So 1 degree alcohol is more acidic compared than 2 and 3. So this is the answer. So the answer depends upon the inductive or plus I effect. Okay. Now the second question. And then now fifth question. If we give this CH3, CH2, OH, and I give you this phenol. Then ask you which is more acidic. So we know that this is this bulky group, this is R group, and it shows plus I effect. It pulls the electron towards the oxygen, so electron density of oxygen is increasing. This group pulls the electron on the oxygen, so the electron density on the oxygen is increasing, as well as the tendency to release this hydrogen is decreasing, as the tendency to donate this H plus is decreasing, so the acidic nature decreasing. But on this group, resonance occurred, plus R effect is occurred. For this reason, electron on the oxygen is busy to create resonating structures. So the bond of hydrogen, as it releases its lone pair to form a double bond of pi bond, it shows positive charge, so it pulls the electron from the hydrogen or this bond. So this hydrogen can be released easily. So due to this resonating effect, the H plus is donated easily, but due to this I effect, H plus does not donate or cannot be donated easily. So if we compare those two compounds, we see that it releases the hydrogen, but it does not release the hydrogen, as it is donate the hydrogen or H plus. So it shows more acidic compared this aliphatic alcohol. So aromatic alcohol shows more acidic compared than aliphatic alcohol, because this alcohol shows plus R effect, that is resonating effect, and this effect shows plus I effect, this is inductive effect. Now the next question. If we take ethanol and if we take phenol, okay, which is more nucleophilic product. So if you compare their nucleophilicity, we see that ethanol is a good nucleophilic substance. This is the short question that you should give answer. Next, the question is ethyl alcohol. You take ethyl alcohol and you take ether, that is maybe C2H5O, C2H5. Okay. Which is soluble in water and why? This is depends upon hydrogen bonding. So we see that the hydrogen bonding is possible in this compound. Finally, if we write this in this way, C2H5, okay, I write this O, C2H5, C2H5 means this, C2H5, O, I have written, so H is here, so H, it's react with water molecules, that is H2, so this H2O, this water molecule is joined with another C2H5, so OH, and C2H5. So it shows fine hydrogen bonding. So where the hydrogen bonding is possible, the solubility in water is possible. Okay. So the answer is hydrogen bonding. Now the next question. is, give example of protic solvent and aprotic solvent. Protic solvent and aprotic solvent. Protic solvent means ethanol. This is protic solvent. And aprotic solvent means, as we saw, it can form hydrogen bonding, but diethyl ether, it cannot form hydrogen bonding, or it cannot form hydrogen bonding. So this is protic solvent. It can donate its H. It cannot donate its H plus as compared to. So the answer on hydrogen bonding. So this is the simple answer. Answer on hydrogen bonding. It shows hydrogen bonding. It does not show hydrogen bonding. So this is protic solvent and this is aprotic solvent. Example. Okay. Now I give you some reactions. One is, I give you CH3, CH2, CH2O, CH3. I give you this. It reacts with HBr. What will be the product? First problem. And the second one is, I give you OCH3. If you take concentrated HNO3 and H2SO4, what will be the product? Third one, I take HBr, OC2H5, I take HBr, what will be the product? Then I give you fourth problem, CH3 whole 3, C, O, C2H5, it reacts with HI, what will be the product? H. So those are the simple problems. Give the answer. Yeah. So it is very easy. This is nitration. So you get from here two product, OCH3. You can write NO2 plus, or you can write NO2 on the para position. Simple reaction. For here, the simple trick is CH2Br is removed from here. H is. This is not mechanism. This is simple tricks. So the product is phenol and C2H5Br. Okay. Now here I is joined here. So the problem is CH3 whole 3, CH3 whole 3 C, CH3 whole 3 CI, and finally C2H5OH. C2H5OH. This is the second product. And here, this is the long chain and this is short chain. What will be the product? Long chain forms alcohol CH3, CH2, CH2OH, and short chain form haloalkane CH3Br. This is the very important. The long chain is going to form alcohol and short chain is going to form alkane. If you take concentrated HNO3 and concentrated HNO3 and H2SO4, nitrogen is occurred, and we know that on ortho position NO2 is coming and on the para position NO2 is coming. If you take HBr and OC2H5, C2H5 is going to form haloalkane and is form alcohol or phenol. This group, this is 3 degree carbon, so as it is 3 degree, it forms I. So this is I, and it forms alcohol. This is ethanol. Okay, so those are the simple reactions and important reactions, not for only Hs but for also JEE and NEAT. Okay, very important. It's not so hard, but there is a logic. You may confuse about it. Okay. Now I am going to write some name reactions. This is the last part of this chapter. Okay. So I write name reactions. Name reactions. First name reaction. Okay. Cumene process. Okay. Cumene process. The process is, if you take CH3, this is cumene. Okay. If you oxidize it with the German oxygen, you get that CH, you can write COOH, CH3. Okay. Then you get here CH3CO. This is simple tricks, not the mechanism. It helps you to remember. Okay. I give you all the mechanism in a video. From alcohol phenol to the last haloalkane halogenanes to the last chapter. Okay, I give you all the mechanism of each and every reaction. So those are the simple tricks. Okay. So this is the process to prepare phenol from the cumene. This is also very important. Cumene to phenol. This is cumene to phenol. Cumene to phenol. Then second, number 2 is Williamson synthesis. So what is the Williamson synthesis? This is RONA, and you write here ROH, R-OH. Okay, you get RO R-. This is a simple process. This is the Williamson synthesis. Just like if you get CH3ONA and if you react with C2H5OH, so the product will be CH3OC2H5. Okay, so this is Williamson synthesis. I just revise it. All is given on my video. Okay, I just revise it. Number 3, coupling reaction. Number 3, coupling reaction. So coupling reaction means you take benzene diazonium chloride with phenol. You can write this benzene diazonium chloride with phenol. You get benzene and N double bond, this also, and you write it ONA, Na plus O minus. So this is the coupling reaction. Okay, benzene phenol. So this 8 Cl is removed from here by using NaOH. Okay, you get this product. Fourth one, HBO reaction. Fourth one is HBO reaction. Okay, if you write CH3 bond CH double bond CH2, if you get this product 3 molecules. If you take this product 3 molecules and you react with B2H6, but B2H6 not, you react half of B2H6, so BH3. So you get this CH3 CH2 CH2 CH3 CH2 CH2 CH3 CH2 CH2, all are connected with D. Okay, and if 3H2O2, if you give this side product, so the product is 3CH3 CH2 CH2OH. This is the product. This is HBO method. HBO method, hydroboration oxidation. Very easy. If you take 1, 2, 3, so this is propene. If you take 3 molecules propene, you get 3 molecules alcohol. This is the process of HBO by using B2H6 and H2. Okay, if you take 3 molecules this propene, you get 3 moles alcohol. Propanol. You take propanol, you get propanol. Next is Cumene reduction. So Cumene reduction means you can take CH3C double bond O CH3 and it reacts with Zn and Hg and HCl. What you get? You get that this is, remove this oxygen and H2 is putting here. So CH3 CH2 CH3. Very easy process. You remove this oxygen and put 2 hydrogens. Okay. Now the next one, Friedel-Crafts alkylation and acylation. So Friedel-Crafts alkylation and acylation, as you know it is very simple process. OH you take you can take CH3 for alkylation CH3Cl and anhydride AlCl3. For acylation CH3 acyl group CH3COCl and anhydrous AlCl3. AlCl4 occurred here, AlCl4 occurred here, so CH3 here, so the product is OH and CH3 as the product. It may be the ortho position or it may be the para position. Okay. So if you take this acyl group, Friedel-Crafts acylation, OH is here, so this is COCH3 plus phenol. You write this para position COCH3. Okay. There is no place. I write this product here. Okay. You can write OH and COCH3. So this is Friedel-Crafts alkylation acylation. Okay. Okay, very good. Then the next is esterification. You take acid RCOH and you take R dash OH. Okay, what will be the product? The product is ester RCOO R dash. OH and H is removed from here, so the product is RCOO R dash. This is the product. This is esterification. Now the next one, OMDM. Okay, OMDM reaction. So OMDM, for OMDM you can take CH3, CH double bond CH2. For OMDM you can use mercuric acetate HgOSc whole 2. Okay, then you can use sodium borohydride NaBH4 and water also. What will be the product? The product is CH3CH less hydrogen negative. For OMDM less hydrogen negative. Okay, so less hydrogen, this is more hydrogen, so positive here, so you add the H here and you add the OH here, so product is OH and this is CH3, 2 degree alcohol. Okay, this process is called OMDM process. Now Rearrangement. Now the reaction is Rearrangement reaction. For Rearrangement you can use this phenol. I take a speed, okay, because already given on my previous video, so I take a speed. That's why I get few times to finish it. Okay, so you take NaOH and CHCl2 and CO2. Oh, sorry, CO2 not H2O, and you get the product that is salicylaldehyde. What is it? Salicylaldehyde. Now the next reaction is Colby reaction. For Colby reaction you can write it NaOH and CO2 and the product is salicylic acid. This is Rearrangement reaction, this is Colby reaction. If mechanism is very important for those two reactions. Just open your NCERT, you take it or you copy it. Okay, I give you all the mechanism from the last video of organic chemistry, from haloalkane haloarenes to nitrogen organic compounds. Then nitration. Then the reaction is nitration. You to take this OH. If you use dilute HNO3, dilute HNO3 and H2SO4, you get this product on octo position NO2 and the as well as the para position NO2. But if you take concentrated H2SO4, concentrated means H2SO4 HNO3. Concentrated means the concentration of NO2 is high, so you get picric acid. So you get picric acid. Okay, you get picric acid. This is nitration. If you use dilute HNO3 and H2SO4, you get these two products. If you use concentrated H2SO4 and HNO3, you get picric acid. Okay. Then halogenation, or you can say it bromination. So the next reaction is halogenation reaction. For halogenation reactions, if you take this phenol group and you give Br2 with the presence of CH2 and CHCl3, you get this product, bromine on the ortho position, bromine on the ortho position, and bromine on the bromine on the ortho position and bromine on the para position. Bromine on the para position. Okay. If you take Br2 aqueous Br2, okay, that means you get this product OH from position number 2 bromine, position number 3 4 bromine, position number 5 6 bromine. Okay, so you can write 2 4 6 tribromophenol. So this reaction is bromination. If you use CH2 as a solvent and Br2, then get both orthobromophenol or parabromophenols. If you use aqueous Br2, you get 2,4,6 tribromophenol. This is bromination reaction. Okay. Okay. The next reaction is Fries rearrangement reaction. What I say? Fries rearrangement reaction. So you take phenol, pyridine as a solvent, NaOH, okay, and you can use CH3COCl as acyl chloride. What will be the product? The product is phenol on the ortho position COCH3 and the para position COCH3. This will be the product. This is Fries rearrangement reaction. Okay. Due to rearrangement is occurred here, so this is called Fries rearrangement reaction. Very easy. CH3CO. So you just remember it. CH3CO is taking their place. Sorry. So on the ortho position and the para position. Okay. This is Fries rearrangement reaction. Now the reaction is iodoform reaction. You take 2 degree alcohol, CH3CHOH, 2 degree alcohol, and you used I2 and NaOH for this iodoform reaction. You get CHI3 as it gives you yellow precipitate. So it is identification reaction. If I ask you, write the difference by a reaction from 1 degree alcohol to 2 degree alcohol, you can say if I take Na2OH, 1 degree alcohol is not responding, but 2 degree alcohol gives you the product yellow, which gives you yellow precipitate. You can say it. It depends on the compound. It may be yellow, it may be green, maybe etc. Okay. This is iodoform reaction. Iodoform reaction is very important. Now the reaction is Barch reaction. Okay, if you take phenol and sodium and liquid ammonia. The product is this. This is Birch reaction. Then oxidation. If you take phenol and oxidize it with the help of K2SO4, okay, dilute HCl, you can write it dilute HCl. With the quinone is separated. OH and OH. So this is oxidation. If you take reduction, Zn dust, with the help of Zn dust, so the name of this reaction is reduction, okay? Zn dust, then you get cyclohexanol. Reduction. This is oxidation, this is reduction, this is Birch reaction. Very simple. So the next, Lederer-Manasse reaction. Lederer-Manasse reaction. So this is called Manasse reaction. Okay. If you take phenol and formaldehyde with the help of NaOH and H2O and HCl, so you get the product CH2OH on the ortho position and as well as the para position. Ortho position as well as the para position. This is very important reaction. And the last one, MPV reduction. MPV reduction. So what will be the condition if you take RCOR or you take CH3CHOH CH3? If you take this and for by the MPV reaction you get RCHOH. This replacement is here. This replacement. This is hot trick to remember. MPV reduction plus CH3CO CH3. This will be the product. Okay. So this chapter is finished here. Is over here. So you all covered haloalkane haloarenes and then you finish this chapter alcohol phenol ether. Okay, you practice those two chapters, then I am coming on aldehyde ketone ether, aldehyde ketone and carboxylic acid, and then there is one chapter is left. So your organics over here after complete my next videos on aldehyde ketone, carboxylic acid and the nitrogen organic compounds. Okay, amines, mainly amines. So take care of your health, revise it, see the video, okay, fully, not partially, remember. Okay, take care of your health. Thank you so much. Bye.